Good morning, seventh graders. Today we are going to be working on lesson 912, which involves finding the area of circles. Last week you worked on circumference, but now we're moving on to area. If you want to follow along in your book, it's lesson 912 on page 495, but I'll walk you through a few things on these slides here. Just to review, circumference is the distance around a circle, diameter is the distance across the center of a circle, and the radius is the distance from the center to the outside of the circle. And when we looked at circumference, we discovered that pi, the number we use is 3.14, really comes from that comparison of the circumference to the diameter, that about 3 diameters would wrap around to make the circumference. But today, however, as we move on from circumference to area, we need to be careful on a couple things. When we work with perimeter, we need to make sure that our units are just linear units, and whenever we work with area of any figure, they are units squared. If we start with a circle here that is sitting inside of this larger square, and we find the area of the larger square of 100 units, and we take the area of the square that is sitting inside the circle, which would end up having an area of 50 units because we can divide it into triangles and find its area to be 50 units. We can overlap those together and realize, if we look at the red square compared to the blue square, that the circle actually lands in between the two squares, and that area of the circle is about halfway between there, approximately. And we can say, well, if we have 100 units for the large square and 50 units for the smaller square on the inside, about halfway between that would be 75, which really is justified by taking 3 times the square of just the radius. And again, remember, as we come with square units, we need to square and multiply some values together. CPM has this really great tool that is linked in these slides that you can play around with if you'd like, but I'll show you a little bit of how it works. So as this opens up here, you can see the circle, and it's divided into 2 colors. And if I drag the bar here, the circle is going to be rearranged, and the sections from the bottom are going to lay out with the sections from the other half coming over on the top. It looks kind of like a wavy caterpillar type shape. If I put it back as a circle, we can see that the parts that were almost like triangles rearranged to come back to the circle. If we increase the number of sections in the circle, and we'll go, let's see here, to 60, it's about the halfway point on the drag, and I rearrange this again, as this folds up like a comb on here, we start to see a shape that we are very familiar with, and that would be a parallelogram. And there is a big correlation between finding the area of a circle to the components of a parallelogram. As we looked over here on the side, we can put the circle back and realize, oh, that's the radius, which correlates to the height of this parallelogram. And the side that is laid down really comes to be about half of the circle, or half of the circumference. And since we took the diameter times pi to get the circumference, and the radius is half of the diameter, down here on the tool it's showing us r times pi, which is radius times pi. That cool tool is something, again, that's linked for you to look at. This video is another representation of how it works.
Pi r squared gives you the area of the circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.
So that formula now, area is equal to pi r squared. We are going to use the value of 3.14 for pi and revisit the circle from the earlier exercise with the red and the blue squares around the outside and then the inside of here. And if I find the radius, which in this case is 5, I will square that radius and multiply it times pi, and I will get a more precise measurement of the area of this circle at 78.5 rather than our estimate of 75, which was halfway between the 100 and the 50. There is another video linked for you today, in addition to these slides, which walk you through and give you some links that break this down if you need to refer back to this. But this Math Antics video here is one that is going to be linked for you if you feel like you need some more information or more practice as you continue with your homework. Your homework for today is going to be a Google form, which has you calculating circumference, diameter, radius, and area of various circles. Thanks. If you have any questions, feel free to reach out.